For this lesson, we'll explore solving equations with rational expressions. So for our first example, we're asked to solve x over 3 plus 1 equals 1/2. This isn't a traditional rational equation because we actually only have like numbers in the denominator, but still the technique we would use to solve this is the same technique we could use to solve any rational equation. It doesn't matter. The easiest way to start off is really just to get rid of the fractions, because fractions are what's causing the problem. So to get rid of the fractions, just identify what the lowest common denominator is. And so looking at this, let me make sure I pick my pen. So looking at this, I'm going to say that the lowest common denominator, sorry, that's LCD, not LED. The lowest common denominator is going to be 3 times 2, because here we see the denominator of the first thing is 3, and the denominator over here is 2. They have no common factors, so the LCD would just be 3 times 2, which is equal to 6. Okay, so that's the least common denominator. Let's multiply both sides of our equation by that. So let me rewrite the equation. We have x over 3 plus 1 equals 1/2. Let's multiply both sides by our LCD, which is 6. Now we need to distribute the 6, and that gives us 6 times x over 3. Well, 6 divided by 3 is just 2, so we're left with 2x. Next, 6 times 1 is just 6, equals 1/2 times 6. Well, again, remember 6 is the same thing as saying 6 over 1. So 1/2 times 6 is 6. 6 divided by 2 is just 3, so simplify, and we just get 3 over there. Let's finish. So this is now just a linear equation. We can solve a linear equation by just getting x on one side and the numbers on the other, and we're left with 2x equals -3. Divide by 2, and we get x equals -3/2. And that's our solution. In this case, it wasn't completely relevant, but when we are solving rational equations, you know you're not allowed to divide by 0. So we really should check our answer to make sure it's not going to cause any of the denominators to be 0. Since in our original expression, we didn't even have any x's in the denominator, that's not going to be a problem. But this is our solution, and we can check it, of course, by plugging it into the original expression. Let's move on to a new example. In this example, we're asked to solve 2 over a plus 5 equals 1/3. We can do this by the method we just saw, and we just need to find the LCD. So our lowest common denominator, well, here we have a denominator of a plus 5. Here we have a denominator of 3. Again, there's no common factors, so our LCD is just going to be 3 times a plus 5. Okay, so let me multiply both sides by that LCD. So we have, let's see here, we have 2 over a plus 5 equals 1/3. Let's multiply both sides by 3 times a plus 5. Okay, there's actually nothing to distribute here, so we can actually cancel. Let's see, here we have an a plus 5 that will cancel out with this a plus 5. Here we have a 3 that will cancel out with this 3. Again, they're canceling to be 1. So let's see, we have 3 times 2 is just 6. And 1 times a plus 5 is just a plus 5. So now to solve, let's subtract 5 from both sides, and we're left with a equals 1, because 6 minus 5 is 1. Now again, we should check. Would a equaling 1 cause anything in our original expression to be divided by 0? Well, no, because 2 divided by 1 plus 5, well, 1 plus 5 is just 6, and 2 divided by 6 is 1/3. So this works out and doesn't cause any problems, and this is our solution. There is another way to do this that I'd like to show you really quick, because this is a very common technique used in science classes. Whenever we have a single fraction, like 2 over a plus 5, equaling another fraction, there's something called cross multiplying. And it only works if you have a single fraction over another single fraction. The idea is that we could just take this 2 and multiply it by the denominator of 3, and take the 1 and multiply it by a plus 5. So that's going to give us 2 times 3 equals 1 times a plus 5. Now, if you notice, this is actually the exact same thing we did over here. It's just a different way of thinking about it. This is a very common technique in science-based classes, but it really is the same thing as multiplying both sides by the LCD. So it's not a new technique. It's just a different way to think about an old technique. But anyway, simplifying this, of course, we get 6 equals a plus 5, and we're back to exactly where we were a moment ago, where a is going to be equal to 1. And again, this technique is called cross multiplying, but it only works when you have a fraction equal to another fraction. Okay, moving on to our third and last example. We have x over x squared minus 9 minus 1 over x plus 3 equals 1 over 4x minus 12. So let's find the LCD, but this time it's not quite as obvious what the LCD even is. So let's rewrite this. Let's see, we have x over, I'm going to factor each denominator to make it easier to figure out what the LCD is. So we have a difference of 2 squares, so that factors to be x plus 3 times x minus 3 minus 1 over x plus 3 equals 1 over, this one has a GCF of 4, so I'll pull out a 4, and I'm left with x minus 3. Okay, now it's a little bit easier to see what our LCD is. Our least common denominator, again, we can find this, we've talked about this before, by multiplying each factor to the highest power that factor appears. So here we have an x plus 3. We also have an x minus 3. Looking at our second one, we have an x plus 3, but that's already included, so we don't need to include it again. And then this one has an x minus 3, which again we already have, but it also has a 4, so let's put a 4 in there as well. So our LCD is going to be 4 times x plus 3 times x minus 3. Okay, so now let's multiply both sides by that 4 times x plus 3 times x minus 3. That's the same thing as multiplying each term by that. So in other words, I'm going to multiply the first fraction by that, the second fraction by it, and then the fraction on the other side as well. So let's do that. So we have 4 times x plus 3 times x minus 3 times our first fraction minus, do that again, and this is the same thing as if we were to distribute. So we have 4 times x plus 3, x minus 3 times 1 over x plus 3 equals 4 times x plus 3 times x minus 3 times 1, oops, I kind of ran out of space here, but it's going to be 1 over the 4 times x minus 3. I apologize for running out of space there. All right, so let's see what cancels. The x plus 3's cancel, the x minus 3's cancel. Here, the x plus 3's cancel. And for this last one, which again was really just the 1 over 4 times x minus 3 times the LCD, which I just put on top, the x minus 3's cancel and the 4's cancel. All right, let's distribute what we have. So I'm just going to, well, actually, really, I'm just going to neaten up what I have here. Here I have a 4, and here I have an x, and the denominators went away, so I'm just left with 4x. Here I have a 4, and I have an x minus 3, and everything else canceled. On the right-hand side, I just have an x plus 3 left over. Okay, so now we can distribute and solve. So let's distribute this, and we're left with 4x minus 4x plus 12 equals x plus 3. Okay, let's see, the 4x's should cancel, and now we're just left with 12 equals x plus 3. Subtract 3 from both sides, and we have x equals 9. Okay, let's do one more example. Oh, and by the way, before actually we get to that fourth example. If you look at x equals 9, we should check to make sure it doesn't cause any of the denominators to be 0, and it doesn't. It will solve the equation. For this last problem, let's solve y plus 1 over 3 times y plus 4 equals 8 over y plus 4 times y minus 4. For this one, we can use the cross multiplying technique if we like. It really is your choice. I'd rather use the LCD technique. Sorry about that. I'd rather use the LCD technique. All right, so oops, let me change my pen color. All right, so let's use the LCD technique. First, we have to find the LCD. Well, I see here that I have a y plus 4, y minus 4. This one already has a y plus 4, but it also has a 3. So that means our LCD would just be 3 times y plus 4 times y minus 4. And this one was a little easier to find, the LCD, than the last one because it was already factored for us. Okay, so the idea here is I just want to make sure I multiply both sides by that LCD. So let's do that. Let's take the 3y plus 4 times y minus 4 and multiply it by the left-hand side. So that gives us a y plus 1 over 3y plus 4 equals, and again I'm going to take my LCD and multiply it by the right-hand side. 8 over y plus 4 times y minus 4. All right. Again, at this stage, all the denominators should go away. They should cancel. If they don't cancel, that means something went wrong. And that's our point of doing this whole LCD technique, is so the denominators go away. So let's see here. The 3's will cancel. The y plus 4's will cancel. The y plus 4's will cancel on the right, and the y minus 4's will cancel on the right. So all the denominators went away. Now let's rewrite this so it's a little bit easier to read. And I'm left with y minus 4 times y plus 1 on the left, and 3 times 8 on the right. Let's distribute and then ultimately solve this. Okay, so using FOIL, multiplying the first give you y squared, multiplying the outers give you just y, multiplying the inners is minus 4y, and multiplying the last gives you minus 4. And all this has to equal 24. Okay, continuing along with the simplification, we have just y squared minus 3y minus 4 equals 24. Unlike the previous examples where we had linear equations at this stage, we have a quadratic equation at this stage, a nonlinear equation. The way we're going to solve this one is by factoring, but before we factor, we have to make sure we're using the zero factor property. In other words, 0 has to be on the right-hand side. So to get 0 on the right-hand side, let's subtract 24 from both sides, and we're left with y squared minus 3y minus, well, minus 4 minus 24 gives you minus 28 equals 0. Okay, so let's factor this. Just going through my head, what would work? Well, 7 times 4 does give you 28, and 7 minus 4 gives you 3. So it seems like the factors here would be y minus 7 and y plus 4 equals 0. So now let's continue this over here. Let's set each of these factors to 0, just using the zero factor property. So we have y minus 7 equals 0, or y plus 4 equals 0. Adding 7 to both sides gives you y equals 7, and subtracting 4 from both sides gives you y equals negative 4. All right, so it seems like we're done at this stage, but again, we have to check our answer. It would be great if we actually checked to see if our answer gives the correct solution, but more importantly, we're just checking to make sure that these are valid answers, that these could be, that these aren't going to make the denominator 0. So plugging in 7 into our original expression, well, let's see, 7 plus 4 is 11. 11 times 3 is 33. That's not 0. 7 plus 4, again, that's 11. 7 minus 4 is 3. So again, we're not going to get, what is that going to be? 11 times 3 is 33. Again, we're not going to get a 0 denominator here. What about it when, so this is a valid answer. That one works. All right, what about negative 4? If we plug in negative 4 into this first one, we'd have 3 times negative 4 plus 4. Well, negative 4 plus 4 is 0. So if we plug in negative 4 here, we're going to get 0 in the denominator because 3 times 0 is 0. So that is not a valid solution. This is something called an extraneous solution. You don't have to worry about the vocabulary here for that. But if you're wondering, this is just called an extraneous solution. All that means is that we did everything correctly in terms of the math. We just wound up with something that was extra that doesn't work, that we don't need. So not a big deal. You did everything correct, but you really do have to check your answers for these because we could wind up with these extraneous solutions. All right, so our final answer and our only answer is y equals 7.